dah?
Record dah.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening to everyone. We are from Group 4. Today we would like to present about our assignment project, which is History of Solar Energy and its Revolution. Before that, I will introduce my group member. Firstly, my name is Iqwan Izmi Hafizi bin Mizal. Next is Muhammad Ar-Hakimi bin Rosmi. Next is Nur Ayuni binti Ismail. Next is Nurul Afika binti Muhammad Idris. Next is Siti Umairah binti Muhammad Aziz. And lastly is Tan Cheong Wo. I will continue our presentation with introduction. Next.
So I will proceed to introduction. Solar energy is a type of renewable energy which comes directly from the sun. This energy drives the climate and weather and support virtually all life on Earth. Solar energy technologies harness the sun's energy for practical ends. These technologies date from the time of the early Greeks, Native Americans, and Chinese who warmed their buildings by orientating them toward the sun. Modern solar technologies provide heating, lighting, electricity, and even flight. Solar power is used synonymously with solar energy, or more specifically to refer to the conversion of sunlight into electricity. This can be done either through the photovoltaic effect or by heating a transfer fluid to produce steam to run a generator. Next. This is overview of solar energy history. Next. The history of solar energy. Historian Russell Allback. In 1839, photovoltaic effect discovered by Alexandre Edmond Becquerel. He is French physicist. Next. For the solar cell, in 1953, silicon solar cell discovered by first Kelvin Souter Fuller, second Gerard Brizan, third Darryl Chapin. Next. This is a chronology of solar energy, started from ancient Egyptian, using the sun to dry dead bodies, which is mummification. Following up to 3rd century BC, Greek soldiers burned Roman fleet by using mirror to focus sunlight. At 100 AD, using mica window to store heat of sun and later gave it off. Followed with 1767, the world's first solar collector was built by Swiss scientists. In 1891, the first commercial solar water heater was patented by the father of American solar energy, Clarence Kemp. In middle 1950s, the first solar water heated office building was built by architect Frank Bridges. In mid-1990s, have a few tax credit and incentive for solar electric homes or heating system, yet approximately 1.2 million buildings in the US are solar heated. So this is a solar potential and energy consumption. The energy requirement forecasts that by the middle of century, the global energy demand will at least double. The increasing electrical energy conversion from renewables such as solar energy. The annual solar energy potential of the Earth is 23,000. For comparison, the Earth's total finite energy resources are of 1,655, and the energy that can be converted yearly from non-solar renewable resource in only 64 squared. That's all from me. Proceed to the next slide.
Next, in ancient age, solar slowly moved from the metaphysical approach to more practical application since there are there are usefulness of the solar energy during ancient age, such as people of those days admire the sun and even frequently personified and worship it as a deity. Some of these gods were Amaterasu in Japan. In Greece is Helios and later Apollo. And lastly, Surya, the Hindu sun god. First application is during 6,000 years ago, which is it is connected to architecture. The Neolithic Chinese people had their sole opening of their home facing winter south to catch winter time. The low sun rays for assisting the warmth of the house. 1,000 years later, used by the ancient Egyptian and Greeks, which is Aristotle, in 384 before century until 322 before century. The proper house orientation was taken from the Greeks by the famous Roman architecture, which is Vitruvius in 80 before century until 50 before century. The technology was further developed by applying large transparent single panel windows, single pane windows of mica, translucent marble, or clear glass, acting like a solar heat trap, admitting the sunlight and keeping the accumulated heat inside. Next. The second application is the sun was used to dry and preserve food. The ancient Egyptians used specific dehydration technology to dry grain, formally storing them in silos. It is enabled to keep the stored grain for several years. Third application is salt production, which is the sun was used to evaporate seawater to obtain salt. The salt water was collected in solar ponds, and after the water was evaporated, the salt remained at their disposal. And the fourth application is lighting fire in third century before century. The concentrated wave of the sun can be used for lighting fire. The ancient Greek and Romans used mirror to concentrate the sunbeam for lighting torch. The Greek scientist Archimedes of Syracuse lead Roman enemy a wooden ship by concentrating sun rays. Next. Okay. In Middle Age, during the Renaissance, Leonardo da Vinci worried about the destruction of the Earth's huge forest. He performed several studies concerning the use of the solar energy for heating purpose. In his investigate the geometry of the reflection of parallel sun rays on the curved metal plate, which is obtained a geometric relationship which was independent from the curve of the plate. It proposed the first industrial application of a concave mirror solar concentrator to be used for a water heater. Proposed a technology to weld copper using concentrated solar radiation, the technical solution of heat bathing installation or to operate textile machine. Next. In 1767, the Swiss polymath Horace Benedict de Saussure built his so-called hot box plate collector, known as the world's first solar energy collector. It was a rectangular box made of wood, insulated with black cork and covered by glass. Inside the box was a smaller, similar glass-covered box. When the box was placed in the sunlight, the water from the inner box could boil. The hot box became the prototype for solar thermal collector. Next. Okay. From the Industrial Revolution up to now, during the Industrial Revolution began in Britain in the 18th century, the agrarian and handicraft-based economy was changed by industry and machine manufacturing. The technological advance due to the increasing application of science to industry were connected to enlarged use of iron and steel, a new energy source, including biofuels, which is coal, electricity, petroleum, and motive power, which is steam and internal combustion energy. Radically improved productivity due to the invention of new machines. Important advancement in transportation and communication, which is steam locomotive and ship, automobile, airplane, telegraph, radio, and etc. In this age, also numerous solar energy-related industrial achievements and innovation were reported. Here some specific ones can be mentioned, which is first Adams solar oven, the solar furnace built by Antoine Lavoisier, Minecraft largest sun machine, the sun-powered printing press of Abel Prefer, the solar stirring machine of John Ericsson, the world's first solar thermal power station, the power plant in Vampats Dry Lake, and lastly, the climate solar water heater. That's all from me. Thank you.
Okay, first solar industry, firstly, Adam solar oven. Okay, the sun collector of W. Adams was more efficient than other previously constructed variants. The oven made had symmetrically placed silver glass mirrors forming an octagonal reflector. The sunlight was concentrated by the mirrors into a glass-covered wooden box in which the pot with the food to be boiled was placed. The box had to be rotated by hand to align with sun rays. The temperature in the box could exceed 200 degrees Celsius. Next. Okay, the solar furnace built by Antoine Lavoisier. The record holder at the time in this field was the Frenchman Antoine Lavoisier in 1743 until 1794. Could attain in his furnace 1750 degrees Celsius. The furnace used two lengths of 1.32 and 0.2 meter diameter, made from curved sheets of glass, having their internal space filled by vinegar. Lavoisier was also concerned about the environmental issues connected to burning fuels, intended this way to clearly generate the heat needed for his experiments. Next. Okay, for Montchot's largest sun machine. The French mathematics professor and inventor Auguste Montchot in 1825 to 1911 pioneered this field by developing diverse sun ray powered devices such as ovens, steel pumps, and the first solar steam engine. Montchot's largest sun machine is the greatest such engine. It's made of silver-coated metal plate of 5.4 meter diameter, having a total collecting area of 18.6 meters square and its moving parts were of 1,400 kilograms. Next. The Sun Power Printing Press of Abel Pfeffer. The developments of Mount Sharp were continued by his assistant Abel Pfeffer in 1852 to 1928. His solar collectors were parabolic reflectors made of very small mirrors. Shape was slightly similar to Marcott's truncated cones. Used a concave 3.5 meter diameter mirror having in its focus a cylindrical steam boiler. The generated steam actuated a small vertical engine of about 3,000 watts, driving a printed press. Next. The world's first solar thermal power station, built in 1912 by Frank Schumann in 1862 to 1918. He is an American solar energy pioneer. It's the world's first solar thermal power station for a pumping plant in Midi, Egypt. The system was using several 62-meter-long cylindrical parabolic-shaped cylinders to focus sunlight onto an absorbing tube. The cylinders covered totally more than 1,200 meters square area. The solar engine was able to develop 37 to 45 kilowatt power continuously for a 5-hour period. It enabled the pumping of more than 20,000 liters water per minute from the Nile to the adjacent agricultural fields. Next, the power plant in Invampa Dry Lake. It's built in February 13, 2014. The world's largest such power plant was opened in Invampa Dry Lake in California, United States, America. The Invampa Solar Electric Generating System nominal power is 377 megawatt. Over 300,000 software-controlled mirrors are tracking the sun in 2 dimensions and reflect the sunlight to the boilers placed atop of 3 140-meter tall towers. Next. Climate solar water heater. The first commercial product which overcome disadvantages was the climate solar water heater. It marketed beginning 1891 by his inventor Clarence Kemp. Further improvements were made at the beginning of the 20th century by incorporating sun-exposed pipes and remote inserted storage tanks in which the warm water entered. All this enabled people to enjoy hot water all the day and night. Next.
Okay.
That's all from me.
Further this presentation with working principle of solar cell. Okay. First, before we further what is a solar cell, the working principle of solar cell, we must know what is a photovoltaic effect and photoelectric effect. Okay. Working principle of solar cell is based on photovoltaic effect. Photovoltaic effect is the generation of the potential difference at the junction of two different material in response the electromagnetic radiation. What is a photovoltaic effect? This is the electron emitted from the material that has absorbed the light with a frequency above the material independent threshold the frequency. So this picture show the what is photoelectric. Okay. photoelectric effect can be explained by assuming that light consists of well-defined energy quanta, which is photon. So this is the photon that can absorbed by the material and release the electron. So the energy of photon can be defined by this equation, which is E equal to hv, which is h is Planck constant and v is frequency of light. So this is the working principle of solar energy. This picture is show the layer of the solar cell. The arrangement of the solar energy solar cell like a sandwich is consists N material, P material, the bus bar, which is this negative contact and back contact that collect the positive contact. Okay, so this is the step of the solar working principle. Okay, the first step is the absorption of the photon. Okay, this error and um, this orange color ni is the photon that absorbed by the material in the solar cell, and it is produce electron hole pair is generate and occur due to photoelectric effect. Okay, next for step 2, electron and hole will recombine. So the electron and the hole can be recombined in this region. Okay, step 3, subsequent separation of the photogenerate charge carry in the junction. Okay, with the semi-permeable membrane, the electron and the hole can be separated. Okay, this is the membrane that can separate the hole. This red color is the electron, and the white color is the hole. They can separate by this membrane. Okay, this membrane are formed by N-type and P-type semiconductor material. So the N-type semiconductor material can flow the electron which is negative charge, and P-type semiconductor material um, collect the hole which is the positive charge. Okay, um, step 4 is a collection of photogenerate charge. Okay, the charge will be collected by the metal observed interval, which is bus bar. Bus bar is a electron collecting rail. This is bus bar at the top of the solar cell, and back contact. This back contact, which is it function to collect the hole. So this is the back contact at the bottom of the solar cell. Okay, thrust contributing to the cell output current to the external circuit. So the electron from the bus bar can be flow to the external circuit. So the last step, the electron and the hole recombine. Okay, after the electron pass through the circuit, They will recombine with hole at the metal absorb interval. Okay, so the hole and the electron will combine at this membrane.
Okay, I will continue our presentation with revolution of solar technology. Next. Okay, in the slide you can see the positive of solar power. Alright, I try to summarize the revolution of solar energy. Okay, firstly in 7th century, first use of solar power used to light fire with magnifying glass. Okay, in 17th second, use solar power use sunlight to power oven during long journey overseas. Okay, in 1873, William Albee Smith discovered that selenium had protoconductive potential. In 1883, Charles Fritz produced the first solar cell made from selenium wafer. And next, in 1954, creation of silicon phototype PV cell at Bell Lab. And next, in 1988, solar panel in outer space, Vanguard ice satellite use a 1 watt panel to power its radio. In 1973, first solar power building that Solar One construct at the University of Delaware. And today we can see solar everywhere. We can see the solar which is in home and uh, in leisure place and many more. Okay, next. Okay.
For the development of solar technology in the past 100 years ago, solar thermal energy. From the picture, you can see the renewable energy sources such as solar energy have a biggest demand for future. The energy consumption demand forecast have been shown in the figure until year 21 century. The solar energy was revived in 1990, especially in Japan and Germany, due to several reasons such as global warming, pollution to the atmosphere, energy supply availability, and policy of industrial countries. 1/3 of global greenhouse gas (GHG) emissions are generated by the power sector. This investment need to be replaced by renewable energy technology such as solar thermal energy. After that, we developed the solar energy in the water heating technology. From the picture is one of the example we use to heat the water to get hot water. The well-known major technology for water heating are flat plate collector (FPC) technology and the evacuated tubes collector (ETC) technology. Flat plate collector (FPC) technology use a glass dark-colored or particular called solar heat absorber as the main component of the traditional flat plate collector device. Evacuated tubes collector, which shown in the picture, technology is known as the flat plate technology modification. Evacuated tubes collector technology consumes sunlight thermal energy and then turn into heat that can be used in water heating application. Next. Besides, we also use solar energy in the solar thermal electricity generation. Photovoltaic technology that use sunlight to produce electricity. Solar thermal technology that use solar radiation to generate electricity or to support steam and hot water to provide electricity to a turbine. Due to the turbine performance limitation, the average efficiency of a solar thermal system can be decreased by a total of 20%. Solar thermal conversion diagram for generating electricity shown in the diagram. We can see the solar panel collect and absorb the sunlight energy and it transfer into the turbine, and turbine generate the kinetic energy to generate power, electricity to the power grid. That's all. That's all from us. Thank you.